Hello friends, welcome to the video. In this video, I'll guide you through the basics of Cplex and will solve bin packing problem using it. So the Cplex is an optimization software package developed by IBM. Information this is available in Wikipedia. A free edition of a software is available and can be downloaded from their website. It is available here in the product section and here you can click this link and download the free edition. When the downloading is over, you can install the software into the computer. This can be opened using Cplex Studio. So when we click this, this will open. So this is the place where we write the code, and this shows all our current working folders. We can create a new project in this from here, new OPL project. It's also available in this section. Okay, so we'll create a new OPL project, and since we'll be solving bin packing, I'm going to name this bin pack problem, and we are creating a model for solving this, and we'll be importing the data into the model from a separate data file. So we'll create that as well. We'll click finish, and when we click finish, we can see that two files have been created, binpack.mod and binpack.dat. This is the bin packing problem which we'll solve today using Cplex. So in bin packing problem, we have n items with each volume of Wj and n bins with same volume of C. So our objective is to assign all the items into bins such that the number of bins used are minimum. This is a possible mathematical formulation where xij and yi are the two boolean variables used. These are the decision variables. Xij is 1 if item j is assigned in bin I, and yi is 1 if bin I is chosen. So the objective function is this one, minimize z equal to sigma equal to 1 to n yi. This will give the number of bins required, and there are two constraints in this. The first constraint says that the capacity of any bin does not exceed the number of items in it, and the second constraint says that all items are packed. So now we'll formulate this in Cplex. So we'll start with the code now in binpack.mod. So first we'll create parameters required for solving. So I'll be using int for number of items, that is n, and which is equal, I'll input this from dat file. So I'll write 3 dots. This will mean that the data n, the value n, is taken from dat file. Now again I'll create another range type variable which is an array for item, and this is, I'll create 1 dot n, which means that an array is created from 1 2 3 4 so on n. Similarly I'll do for bin. Now this value, now these also I'll include here the volume of each bins, so that they can be fractions or decimals. So I'll use a float variable, float C for the volume of the bin. This I'll import from that file, and float wj, which is for each item, which I'll again import from the dat file. For the data, in the data file we can write directly as, say I have 10 items, I'll write n equal to 10, and now if I want to import from an Excel sheet, I'll have to create an Excel sheet in which is in this folder. So I have created an Excel sheet named data_bp, and this is my data. The data is available in OR library. So I have 10 items and these are the volumes of each items and this is the volume of the bin. So now to connect this to my Excel sheet, I'll write sheet and connection. This is the function which will connect, and I'll write my underscore sheet, which is the name, and here I'll write data underscore bp dot xlsx. So this will connect. Now to define my variables, I'll write c from sheet read my underscore sheet, comma, and here this is sheet 1 and the element is E3. So I'll write sheet 1 and I'll use to denote this is used to denote the elements which are used, and which is E3. So I'll write E3 and W underscore J from sheet read my underscore sheet 1, and this is from C3 to C12. So I'll write C3 colon C12. So this is how we'll import our data from the Excel sheet to the DAT file. After creating the data, we'll go back to our mod file, and now we'll create the variables, the decision variables. So that is written as dvar. So also you can see that it shows an error here because I haven't completely written it, and this is a good thing that it shows error in real time, so you'll know when it's wrong. So now this I can, yeah, so I need to create two boolean variables x and y. So I'll write boolean and x, now bin and item. So this denotes that there are two indexes of x, and first one represents the bin and second represents the item. So now I'll create a second one, y, which is for bin. So these are my two decision variables. Now I'll write my objective function, which is uh, we need to minimize this number. So the syntax is minimize. Since it's minimize here, I'll write minimize. If it's maximize, then maximize should be written here. Sum, and the sum is I in bin, and the variable which should be minimized is y. So I'll write y, and the number is I, index is I, so I'll give y of I. Now for the constraints, so the constraints are written as subject to. So we'll write a subject to, and then in brackets. So first we'll write in this we can see that this is for all I in bin. So this is for all I, and the summation is from j to n. So we'll write first for all I in bin, and we can actually name the constraint as constraint 1. This is the name of the constraint I'm giving. It's not usually required, but unless like we can use it for post processing later. So this is the name I can give. It's optional. So, and it is sum of j in item. Now this is w into x less than or equal to c into y. So I'll have to write w underscore j. This is of j index into x of phi and j. So less than or equal to, it's written like this, and then is equal to c into yi. So this is the first constraint, and now for the second constraint, the second constraint is all the second constraint is for all j. So I'll write for all j in item, and I'm naming this as constraint 2, and this is sum of all xij is equal to 1. So I'll write sum of I in bin x I j is equal, actually it's I'm assigning, so it should be used double equal to 1. So now the constraints are also defined, two constraints. After the constraints are defined, we can use post processing as well. So for that, I'll write execute, which means that this will be executed after the program is run. So I'll use if cplex dot get cplex status double equal to 1. This will mean that if the program, if it has a solution equal to 1, means that the solution exists. Then I'll say write ln, which means that this will be displayed that items are placed in bins as, and here I'll display the variable which is x. So I should write x dot solution value. This is given that the solution exists. Now if the solution doesn't exist, then I'll display it as error. So I'll write else and write ln error solution not found. So this will be displayed if there is an error. Now to run this, we'll just have to create new configuration. So in run configurations, new, and click on run configuration, finish. So this will create a configuration1 file which is written here. So now we have to copy these two files into here, and okay. Now we can see that these two files are in here. Now we just have to run this. So as we can see in the bottom right corner, it shows the status. So it's still launching. Okay, there is an error. The error is in binpack.dat, which is, oh, we should use double apostrophe here. So after using this, we'll run this again. It's launching 57% and it shows the time as well in the bottom right, which it takes to solve. And now we can see that it the program is run and there are no errors in this. So in this we can see that there's a scripting log. So in the scripting log it is shown that solution optimal with objective 7. This means that the optimum number of bins are 7 and the order in which they are placed is this, which is the first item and the third item are placed in bin 1, the second item is in bin 2, the fourth item is in bin 3, so on up to 7 items. You can see that these ones are only there till 7 and not later. So this is the objective and this is how it's solved. And in solutions also it's there. These values are also shown here in the left bottom. So here we have solved, and in the y, as you can see, there are 7 numbers. So this is how we use Cplex to solve bin packing.